Welcome back. In this video, we're going to go over section 2.6, which is about solving compound inequalities. At this point, we've already looked at how to solve inequalities, linear inequalities, and to write the answers using interval notation. In this section, we look at compound inequalities. And so the first part is to say what a compound inequality is, and then how do you solve those. So a compound inequality is made out of joining together two inequalities using the word and or. So for example, if we have 6x minus 3 is less than 9 and 2x plus 9 is greater than or equal to 3, that is an example of a compound inequality. In going forward, you want to look at something like that as not like two separate problems that need to be done, but instead one problem consisting of two parts. So here, when we say that we're going to solve that, we want to find the x values that satisfy the first part and second part. So we have to have x values that satisfy both of the two inequalities. For the other one, other example, we have 5x plus 1 is less than or equal to 0, or 2x minus 14 is greater than 7. So on this one, we would be seeking the x values that fit one or the other of the two inequalities rather than the first one and the second one. Throughout this section, you want to make sure you're clear about the difference between or and. We're going to start by solving some problems involving and first. So luckily, this is not like super more complicated than what we were doing before. It has more or less one additional step. So we have 4x minus 7 is less than 9, and 5x plus 8 is greater than or equal to 3. So how you'll want to do this is solve each of the separate linear inequalities separately. So 4x minus 7 less than 9, we will add 7 to both sides. So 9 plus 7 is 16. We'll divide by 4. X is less than 4. Okay, so we've gotten that part, and we're just going to put that on hold for just a moment. Now we're going to solve the 5x plus 8 is greater than or equal to 3 inequality. Subtracting 8 from both sides, we'll have 5x is greater than or equal to negative 5. And so dividing through by 5, we'll have x is greater than or equal to negative 1. And so we need to figure out what x values meet both of those requirements. Again, this one has an and in it, so we want the x's to satisfy the first one and the second one. So x is less than 4. A graph of that looks like this. All the x values smaller than 4. And again, here I've got a parenthesis on this one because the 4 itself is not included. And then negative 1, the second inequality, x has to be greater than or equal to at negative 1. So we want the x values that fit both of those, not either, but both. So that would be the x values that range between negative 1 and 4, including negative 1, but not including positive 4. So our final answer is the half open interval negative 1 to 4. Okay, so the steps, just to summarize that, the steps were to solve each of the kind of component inequalities separately, and then interpret the word and to figure out how to combine those two partial solution sets to get an overall solution. Okay, let's try another one that has and in it. So here we have 3x plus 1 is less than or equal to 20. I'm going to solve that one by dividing through by 2 first. If you wanted to distribute first, that will do just as well. So here we'll have x is less than or equal to 3 for part of it. And then for the next one, I'm going to sorry about that, Zoom crashed once again. All right, so let's try that again. So we've got 4x minus 4 is less than or equal, less than 2. 4x is less than 6, and so x is less than 6/4, and that's the same as saying x is less than 3/2. All right, so now we want to figure out how to combine these two so that we get the x's that fit the first one and the second one. So in the first case, we wanted the x's that were less than or equal to 3. In the second case, we want the x's that are less than 3/2. You'll notice on this one, this is different than the preceding example where we had the arrows going in opposite directions. There was a less and a greater. This time they're both lesses. And so you can see the two arrows point to the left. We want the x values that satisfy both of those, the first one and the second one. And so that will be the x values that are smaller than 3/2. So it'll be negative infinity up to, but not including 3/2. Those will be the x's that fit the first one and the second one. All right, here's one for you to try. Take a minute, pause the video, try this one yourself, then restart the video and see how you did. All right, so for this one, I'm going to start with the inequality on the left. We have 1/4 x. I'm going to add the 3 to both sides, and so that will end up being 2 on the right side. And then let's multiply both sides by 4. X will be greater than or equal to 8. Okay, let's just put that on hold for a moment. Distributing the -3 here, we'll have -3x plus 6 is greater than or equal to 2. Subtract 6 from both sides, we'll have -3x is greater than or equal to -4. Then we're going to divide through by -3. And as you remember, when we're dividing through by a negative, the direction on the inequality sign is going to change. So that'll be x is less than or equal to 4/3. Okay, so for this one, we have in the first case, the x's had to be greater than or equal to 8. In the second case, they have to be less than or equal to 4/3. Well, a little thinking about that, we need the x's that are simultaneously bigger than 8 and also smaller than 4/3. And there aren't any, right? And so for this one, there's no solution. No solution. You could make the empty set, which is kind of a fat 0 with a slash through it, or a pair of curly braces that are empty, that is with nothing enclosing them, or enclosing nothing. In this case, there was no solution. There were no x values that fit the first one and the second one. All right, moving along, we want to look at three-part inequalities. Three-part inequalities have the format like this one, -5, and then an inequality sign, 4x minus 1, another inequality sign, and then a 7. These inequality signs could be either less thans or greater thans, either way, or both. They could be less thans or less than or equals. In any case, they're going to point in the same direction. If you have A is less than B is less than C, this is an abbreviation for A is less than B and B is less than C. This is kind of a shortened way of saying this two separate inequalities joined by an and. It's important to note that the two inequality symbols will always face the same way. You'll never have something that looks like A is less than B, which is greater than C. That doesn't make any sense. And A is bigger than B, which is less than C. Also, you will never see that. Okay? The directions on the inequality sign should always point the same way. All right, so let's try solving one of these three-part inequalities. How you do it is going to be the same, essentially, as how we would solve other inequalities. That we're going to apply the same step to each part here. Here we have 4x minus 1 in the middle. Our goal is to isolate x, so we'll start by adding 1 to all three parts. This being our first one, I'm going to show that addition of 1 all the way across. So we're adding 1 to all three pieces. -5 plus 1 is -4. 4x minus 1 plus 1 will just be 4x. And then 7 plus 1 will be 8. All right, now we're going to divide all the way across by 4. So that will give us -1 is less than or equal to x is less than or equal to 2. So our x values fall between -1 and 2. And so that will be our final answer. You can, if you want, rewrite this inequality as -5. Sorry. Let's make that a little smaller. -5 is less than or equal to 4x minus 1, and 4x minus 1 is less than 7, and then operate on it the same way as we did our preceding examples. But I find this to be more writing. I think you're better off just processing it as a three-part inequality. All right, here's one for you to try. Take a minute, pause the video, and try yourself, and then restart the video and see how you did. All right, let's take a look. So we have -3 is less than 2x minus 5 is less than or equal to 1. So here I'm going to start by adding 5 to all three parts. Okay. Here I wanted to show that addition of 5 all the way across. If you don't feel like writing all that, it's okay. If you're comfortable, you can skip straight to the next step, which would be 2 is less than 2x is less than or equal to 6. And then we're going to divide through by 2. So this will give us 1 is less than x is less than or equal to 3. Okay, make sure that you pay attention to the less thans versus less than or equals. We should have a parenthesis on the 1 side and a square bracket on the 3 side. Right, so we're about halfway there. In the next part, we're going to work on problems involving or. So the overall steps to take for these problems will be similar. We're going to solve each of the separate inequalities separately and then combine the solutions to those using or. So let's take a look. We have 1 minus 2x is less than or equal to -3, or 7 plus 3x is less than or equal to 4. So first step, let me work on the one on the left. 1 minus 2x is less than or equal to -3. So adding 1, we'll have subtracting 1. We'll have -2x is less than or equal to -4. And then we're going to divide through by -2. So x will be greater than or equal to +2. So here, again, we are dividing by negative, so we'll change the less than or equal to a greater than or equal. And then -4 divided by -2 will be +2. Taking a look at the next one, we have 7 plus 3x is less than or equal to 4. So we'll start by subtracting 7 from both sides. So we'll have 3x is less than or equal to -3. Dividing by the +3, we'll have x is less than or equal to -1. Okay, again, a picture to go with this. We'll have -1, 0, 1, 2. In the first inequality, we had x's that were 2 or more. And then in the second inequality, we had the x's that were less than or equal to -1. So if this problem was and, then the answer would be no solution because there's no x's that fit in this one and that one. But here we're looking for the x's that fit one or the other. So this will be -infinity to -1 union 2 to infinity. So we use this union symbol to join together the two intervals when they're separated like that. All right, here's one for you to try. So take a minute, pause the video, and try it yourself and restart the video and see how you did. Okay, so I'm going to work on the one on the left first. We're going to add 7 to both sides of the first inequality. This will give us 3/5 x is less than or equal to 6. And then I'll do this in 2 steps. Let me multiply both sides by 5 first. We'll have 3x is less than or equal to 30. And divide through by 3, x is less than or equal to 10. Okay, next step, let me multiply both sides by 3 to clear this fraction out. We'll have x plus 6 is greater than or equal to -6. Now we're going to subtract 6. X is greater than or equal to -12. So again, a picture may help. We have -12 on the left, 10 on the right. We want greater than or equal to -12 and less than or equal to 10 on our picture. Here we're looking for the x's that fit one or the other of the two inequalities. Between the two, that actually covers the whole real number line. So our answer here is all real numbers. Okay, and that is the answer to that. All right, that takes us to the end of section 2.6 on compound inequalities. If you have any questions on that, let me know and have a great day.